Hi, kids. We're going to talk about random variables today. And so we're going to jump into it. There is a note sheet that goes along with this if you want to look for it on the website, linked in the calendar maybe, or in a handout section. I'm not sure how it would be organized for you, but there is a note sheet. You don't need the note sheet, but it may be handy. So before we start, quick reminder about A and B. We know that the probability of A and B is equal to the probability of A times the probability of B given A. This actually comes right from the definition of conditional probability if we divided both sides by probability of A. That is the conditional definition. If A and B are independent, then probability of B given A is the same as the probability of B from the test for independence, and therefore we could say that probability of A and B is equal to probability of A times probability of B. That's only if they're independent. For today's lesson, we're going to be using this row in the formula chart for AP. If you still have yours, take a look at the formula chart. We need to make sure we know how to read this. So when we're looking at this, I can see that the mean of X is equal to the expected value for X. We read this E of X as expected value for whatever X represents, which is the sum of each individual X times its probability. I'll show you what that looks like in just a second. And then the standard deviation for X is equal to the square root of the sum of each X minus the mean, right? This gives us a deviation score. Square them to make them positive, so when we add them together, they don't cancel, times its probability. All right, so we'll go through those formulas here in a minute, but those are the formulas that you need. And you need a graphing calculator. Really important for today that you have your graphing calculator. All right, so our life insurance problem. So when we're looking at this, we can see that we're reading this from the viewpoint of the life insurance company. The life insurance company collects $50 per policy. And in 1 year, if you die, they're going to pay out $10,000. And if you become disabled, they'll pay out $5,000. And if neither happens, then they keep your money. So we're looking at this as profit for the company. So X is profit. When we're trying to fill out this table, because they take your $50 to start with, they're holding on to that $50. And then if you die, they pay your estate $10,000, but they're not out $10,000. What they've lost is $9,950. Disability, they're paying out $5,000, but they started with $50. So they're out $4,950. And if neither of those things happen, pretty sweet, they get to keep $50. Now, the probability of death is 1 in 1,000, they think. 1 divided by 1,000 is 0.001. The probability of disability is 2 in 1,000, 0.002. And then these have to add up to be 100% of the outcomes, either death or disability, or neither must be 0.997. So here is X. X equals profit. Here is the probability that our random variable equals whatever these X's are, these X's, right? So our profit could be negative 99.50, negative 49.50, or $50. So our expected profit is equal to the mean. Mean of X is E of profit here, or X equals profit, or E of X. And we take each individual X times its probability and we add them down. So it's this times this, plus this times this, plus this times this. Now we have to show this work, but I'm not actually going to type it in the calculator like this. It's certainly not hard to do. We could, but I'm going to use the list function on my calculator. So what I would tell you is this is going to be list one, which is our x's, and then we're going to use a frequency list. List two is the frequency that this happens, right? About 1 out of 1,000 people that we write policies for is going to die. That's a frequency. 2 out of 1,000 will become disabled, but 99.7% of the people that we write policies for, nothing's going to happen, which is hopefully if we write a lot of policies, we're going to make a lot of 50 bucks. All right. So get out your graphing calculator. Roll on down through here. We have all of that. And then put everything into the lists like we just talked about. And then we're going to go to stat, go over to calculate. We're going to use one variable, statistics. What is our variable? Our variable is profit. Okay. And in list one are my profits, and list two is the frequency of those profits. So we're going to use list two for our frequency list. And then I go to calculate. When I do that, you can see that I get the mean right there. 30 is the mean. Little foreshadowing, also see the standard deviation here, which I'm going to need in a second. But there's my mean. Mean is 30. So when I go back to the work that I had, I know that that's equal to 30. Now we're also going to find the standard deviation, and the standard deviation of x is equal to the square root of each x minus the mean squared to make it positive. This is called a deviation score. It's how much this x deviates from the mean. And then squared to make it positive minus the mean, times its probability. So we do that 3 times. And when we're all done, we're going to get the same thing. Now, you could type this in. It's not that bad. There's not that many of them. But we're going to get the same thing that we got on our calculator, which, if you remember, 386.782. Or since we're going to dollars and cents, you could round it off right there if you wanted to. All right, so we have our mean is each x times its probability. Standard deviation, the deviation score squared times its probability. Add them all together. Take the square root. There we go. Now, that's a lot of deviation, really. And so if we deviate very much from our $30, we really could end up in the negative really quickly if we're on the wrong side of that standard deviation. Okay, so all those things that we just did, we did. Now, we're going to find the expected value and the variance. I changed this up a little bit from the original note sheet. Expected value and the variance. Now, remember that variance, when we're thinking about this, variance is equal to the standard deviation squared. So first, the expected value. Again, we have to show the work. Here's 4 of them. So even now, like ellipses would be kind of questionable. We're going to do each x times its probability. I don't know what these x's stand for, so maybe this is a grade distribution in a class or something else. We have each x times its probability. That's going to give me the mean. And then the variance, I'm just not taking the square root when I go through and do the standard deviation. So go ahead, pause the video, and then you can find the mean and the standard deviation for this probability distribution. I'm going to go in and put it into my lists as we're talking. Now, if we use the lists here like this, and I go to stat, and I go to calculate, and I go to one variable statistics, again, list 1 for my x's, list 2 for my frequency list, there's no variance here. I have the mean, 74. I have the standard deviation, but I don't have the variance. So when we go through and we're trying to do the work, here's the mean, each x times its probability. We got 74. We got to show this work. It's required for AP. We don't have to show the formula, but we have to show each x times its probability. We get 74. When I'm going to show the work for the variance, I'm really just doing the square of the square root. So I just don't put the square root everything. Now, we have the variance is 84, but if I'm using the list, I only got 9.165 from my graphing calculator. So you have a choice. You can try to write down all these values and square it to get back to something close to 84, but this is rounded. If you're really a fan of calculators, when we go to the VARs button, after I've run the calculation on the calculator, it stores the stat bars. Do you see that? Statistics. So if I want to, I can come here to standard deviation and square it, and I can get the same variance that we had there. If I need to calculate variance, it's a nice way to do it without having to type all those digits in. In any case, make sure that you're showing the work. And then if we want standard deviation, we just take the square root of variance. Okay, most of the time we're not going to be given a table unless it's like maybe a multiple choice question or something. Most of the time we're going to have a problem that we're going to have to interpret. By the way, never round the means or standard deviations to integers, ever. If it happens to be an integer, great. But if it's not, leave it. All right, so we have the Podunk Polar Bears, which is a football team, have 2 games left in their season, and so far they are winless. Experts estimate that the team has a 60% probability of winning their first game of the 2. If they win the first game, then they have a 70% chance of winning the second game. Otherwise, they only have a 5% chance of winning the second game. We're going to construct a probability model. So this is going to be like that table for the number of games that the Polar Bears will win. So when we're making this model, what I'm really thinking is, okay, I have at the top row, X equals wins. And then the P of X equals X. Maybe I went that backwards. I'll just make them the same size so Mr. Yoon doesn't notice. Anyway, P of X equals X. We're going to figure out the probability based on what information they had here, right? So it's possible that we win no games. That would be a bummer, but it's possible. It's possible that of the 2 games remaining, we win one of those, and it's possible that we win both games. Oh, that would be fantastic. What it will go out on a high note after all the losses that we've endured as the Podunk Polar Bears football team. So to come up with these probabilities, I need a different kind of model. What I need is something that's going to help me think through, okay, in the first game, I could win, excuse me, or I could lose. This is the first game. And we see that the first game has a 60% chance of winning. So I know that this is 0.6, which means I have a 40% chance of losing that first game. And then regardless of what happens there, we got to play another game. So I have my second game is going to be here. Now, notice that everything that happens on the next, we could win or we could lose. We could win or we could lose. These are conditional probabilities. What's here is really win given that we lost because we're on the losing branch. Does everybody see that? This is conditional. And this is lost given that we lost. Here's win given. Fix that one. This is win given win and loss given win. Okay, so those are the 4 outcomes that we really have. And then when we multiply down the branches, we're going to be given these other probabilities that end up being the and probabilities that we talked about right before we started the lesson, because to do and, it's A times the probability of B given that A happened. So this will be probability. You'd think I'd learn how to use technology, kids. Probability of win and win. Probability of win and loss. Probability of loss and win. and the probability of loss and loss. Now we got to figure out these probabilities here. It says if they win the first game, then we're on this branch, right? Given that they won the first game, they have a 70% chance, 0.7, of winning the second game. Because right now they're like on a, elevated confidence and everything, but they still could lose 0.3. If they lose that game, then they really start to believe that they're not very good at football. And they only have a 5%, that's 0.05 to win. And 95% chance they're going to go winless after that, right? So to find the and probabilities, we're multiplying down the tree, and I have 0.42, 0.18. If I add those together, I get 60% of all the ones that were win first. 0.002, I think. Nope, 0.02. There we go. Put that decimal point right there. All right. And then these have to add up to be 40%. So this has got to be 0.38. You can multiply it and check. Okay. So what I'm looking for, this is 2 wins. This is the only way to get to 2 wins. Win them both. So this is 0.42 in my model. To get 1 win, I either won the first game or I won the second game. And when we say or, I had win and loss or loss and win, and or is add. So to get the or, I'm adding these two, I get 0.2. And then the last one is 0.38 to go loss and loss. And if I add these up in my model, I get 100%, which makes it a good, valid probability model. So the only thing we were asked to do is construct a probability model, but here it is. If I wanted to know the expected number of wins, I could do the mean. 0 times this plus this times this plus this times this. Or if I wanted to know the standard deviation for some reason, I could find that. Okay. Last example, kids. 2 online gamers named Belieber and Gamer Gal have a long, friendly rivalry. And by friendly, it's probably not very. Belieber decides to challenge Gamer Gal to a duel in a popular online fighting game. Gamer Gal is the superior player at this game and agrees to the online duel with the following rules. First of all, the two will continue to play each other up to 3 times or until Belieber finally wins once. Right? So I'm going to give you 3 shots. But if you don't win after 3 tries, it's over. Based on their differing skill levels, the probability that Belieber wins each game is 40%, and the probability Gamer Gal wins is 60. We knew that, right? So we start off, and we're thinking about using symbols to figure out B for each game won by Belieber, G for won by Gamer Gal, and so on, okay? So without thinking about this too much, it's possible that Belieber just comes out of the gate, first game, wins. Oh, shocks the world, right? Well, we're only playing until Belieber wins or until they play 3 games. So B would be it. That'd be the only game that was played. Or it could be that Gamer Gal wins the first one and then Belieber shocks the world. Or it could be that Gamer Gal wins the first 2 and then feeling very full of herself decides she's going to coast a little bit and Belieber comes back and wins 1. Or it's possible that she just blanks him or her. I don't know who Belieber is. And that are our outcomes. So here's the sequence. Possible sequences of outcomes. We could have this or this or this or this. Now we're going to need these probabilities, and they're recapped on the next page. But notice that the 40% chance to win is only for the first couple times they play. But if Belieber loses twice, then on the third one, the chance drops to 20% to win because no one believes in Belieber anymore. So there's our sequence that we had. In part B, we're going to construct a probability model, which is telling me games won by Gamer Girl. So X equals wins by Gamer Girl. I'm just going to use G since we used that before. And then we're going to have probability that X equals X. And I have, it's possible that she doesn't win any, right? If this happens. It's possible that she won 1 if this happens. It's possible that she won 2 if this happens. And it's possible she wins all 3 and then Belieber goes home crying. To find the probabilities that this happened, we're going to do something similar as far as our tree diagram before. We know that in each game, it could be either Gamer Girl or Belieber. Now, if Belieber wins, that's it. So this tree isn't going to fork here because that's the end of the scenario. But we could keep going, and we could play another one. And if that that stops. But we could keep going, and we can have another game here or this, right? So we could see the outcomes where each time Belieber possibly wins, the tree stops. So the only way to get to 0 wins by Gamer Girl is for this outcome to happen, which, if we go back to the recap, is 40%. So this is 0.4, this is 0.6, this is 0.6, this is 0.4, but this drops, right? This was 0.2 if Belieber has lost 2 in a row, and this becomes 0.8. So we're going to multiply down the rows to figure out what our probabilities are. So we have, this is just 0.4. This is going to be 0.6 times 0.4 is 4. 0.6 times 0.6 times 0.4. Nope, 0.2. I knew that was wrong. Is 0.072. And then 0.6 times 0.6 times 0.8 is 288. All right, so what do we got? We got 0 wins, that's 0.4. 1 win by Gamer Girl would be if this outcome happened, right? This right here is G and B. So to get 1 win is this. 1 win, 2 wins, 3 wins. And we're just looking at down the list. If I go, that is 0.24. If I get 2 wins, it's G and B. 0.072. And 3 wins is going to be G and G, which is 0.288. Now, you should take a second, if this were a quiz test or otherwise, and add these up and make sure we have a valid probability model and that the probabilities do indeed add to 100%. Now, we did that, and then it says, given that Belieber loses the first game. So normally when I do this, okay, probability, something happens given, we're going to say G, outcome, G wins first, or B loses first, or however you want to do it. Well, if G win the first game, we're on this branch, right? And we want to know the probability that Gamer Gal wins all 3 games. Well, we're left with the other 2 because it's given that this already happened. So we can see it visually by looking at this tree diagram and saying, given that this happened, what's the probability these happened? Well, it's just going to be 0.6 times 0.8. But if we use the formula, G wins 3, then what we're doing is we're saying it's the probability that this happened over the probability that all 3 happened. And all I'm doing is canceling this 0.6 out anyway, right? Because this is 0.6 times 0.8 divided by 0.6. Those cancel, and I'm left with those 2 that you see right here anyway, right? So you have 0.48. All right, kids, there's my short video on making a probability distribution. Hopefully you enjoyed it. You understand how to create a distribution, also find the mean or expected value and the standard deviation.